Thank you everyone for staying here. And although I think this is the last talk, but I believe that the topic that this talk is covering is about the top priority for the whole human. So, currently we are talking more about the climate change, the sustainability, and I think the whole human kind is facing challenges, including unchecked carbon emission, as well as underutilization of clean energy, and the inefficiency in energy storage and transmission, and last but not least, the uncontrolled energy consumption in many real-life things. And so to address these challenges, actually in Microsoft Research Asia, we are trying to developing a deep learning, reinforcement learning, as well as the foundation model-based approach towards the more accurate computation for the carbon monitoring, the more efficient optimization for the clean energy generation, and the optimization for the storage, energy storage, as well as the more effective control for the energy consumption reduction. And so the first efforts I would like to emphasize is our efforts on the near real-time global carbon budget. So I think the background is like the mitigation of climate change will highly rely on our carbon neutrality, and also the timely assessment of the global carbon budget as well as carbon emission is very important for this progress. But the challenge is that the existing approach is highly reliant on some computation method, which is very time-consuming. And also, if you want to use some learning-based method, you will face the extremely sparse observation things that will block the more efficient learning on that. So to address that, we actually develop a deep learning-based approach and also leverage the semi-supervised learning framework to combine the physical model together with some historical observation data to achieve our carbon monitoring covering the whole global ocean and land, and with limited observation data. And so regarding the clean energy generation, I think the first critical problem is that we need to make an accurate forecast about this clean energy, like the wind power as well as the solar. And based on this accurate forecasting, we are able to make the whole power grid more efficient and robust to match the power supply and demand. But currently the wind farm or solar farm, you have to face both the time series data for each wind turbine, but also the maybe the spatial relationship between the different wind turbine within an individual wind farm. So here we leverage, it actually causes us to leverage the deep learning approach that can leverage both the temporal module to capture that time series pattern, as well as we use some graph structure to capture that spatial dependency within this wind farm. And based on our new approach, we are able to largely increase the forecasting accuracy compared with some existing method like a transformer or a straightforward combination of the GRU and the GN approach. And so for the clean energy generation, I think the ultimate goal is that you are able to optimize or maximize the efficiency of this clean energy generation. So here we take the wind farm as a consideration, and we find that here you need to maybe control each wind turbine in the wind farm you can control it to adjust the its orientation and through the UR system. And also, we need to notice that within a wind farm, because of the wake effect, different wind turbine could affect the power generation efficiency for different wind turbines. So here we leverage multi-agent reinforcement learning to optimize the coordination of different wind turbine within a single wind farm to maximize the wind farm energy generation efficiency. And so this is based on our collaboration with industrial partners, and we find that our approach can largely increase the power generation efficiency as well as very very efficient computation compared to traditional optimization approach. And so regarding the third aspect of the power storage, I think you all know that at this moment, the energy storage, especially the battery, is very important for the whole clean energy initiative, because the practical applications pose a pressing need for the battery management things. And because if we can proactively make some prediction of the battery, like a remaining life and the state of the health, we are able to detect and interrupt the unexpected fast degradation of the battery. And we believe that it can benefit battery manufacturing process as well as battery usage pattern. And also we are able to increase the battery recycling process. And so to achieve this goal, actually we propose a new learning framework that can, using a deep learning approach, to extract both the intracell and the intercell patterns from the electronic signals. And also, in the battery domains, we are facing also the data sparsity issues, that we cannot get enough data for the battery with different aging condition and also different materials. So here we also introduce this intercell learning approach that can maximize the data efficiency for these battery cycle life prediction things. And so after applying this new framework into almost all the public data set we can collect from the internet, we can find that our approach can largely increase the prediction accuracy compared to some existing state-of-the-art approach. So after we maybe optimize the battery management things, I think the ultimate goal is that we can use the battery storage into the microgrid to increase the efficiency of the whole microgrid. And also based on our maybe a storage strategy, we can maximize our the utilization for the clean energy, as well as to reduce some energy consumption for other maybe fossil fuel-based energies. So here, like in a community, if each building has their battery, and they need to ensure that the battery storage strategy within this single community can cooperate with each other. And also we need to consider the clean energy generation, the timing and the period for each of that. So here we also face the dynamic and diverse consumption patterns for different buildings and different communities. So here we also leverage the multi-agent reinforcement learning approach to model the coordination across the different buildings within these communities, which can largely increase the clean energy utilization efficiency, as well as we can minimize the cost for this community power consumption. And so, but last but not least, we want to talk about how we use reinforcement learning together with foundation models to optimize the HVAC control. And the purpose of this work is that we hope to, through this continuously monitoring the data for the HVAC, we hope that we can control the set point of this HVAC system and to ensure that the whole building is in a comfortable temperature. And also we want to minimize the energy consumption in this system. And here we leverage the foundation models and release its power in the decision making. And here we start with a foundation model, and after integrating it with the offline reinforcement learning and to collect more demonstration from this initial agent, and we are able to collect more high quality demonstration to fine tune this foundation model to get the more strong decision making agent. And we can find that using our new agent, we are able to reduce the power consumption by more than 20% energy consumption. This is actually based on experiments on one building in Microsoft main campus in Redmond in the United States. And also we find our policy can maintain a very smoother temperature switch based on our new policy. And also we observe that our approach is much robust to the dynamic environment and also very robust to the perturbation of the environment. So yeah, besides what we developed for the algorithm part, we also want to contribute more to the whole community. So we open source both our tools and also some framework of this learning approach into the whole community. So we release our carbon monitoring data as well as our machine learning tools on the battery degradation prediction. And besides that, we also release our advanced deep learning-based forecasting framework together with our multi-agent reinforcement learning framework into the public community. Yeah, so but in the meantime, we are very eager to collaborate with more collaborators from both the industry and academia. And we believe that in Japan, there is a great opportunities that both the researchers and scientists from the academia, that we have a great opportunity to collaborate with each other to make a greater progress into this type of priority issues for the whole humankind. So that's all my part. Thank you.